just a shorthand way of writing a longer number. We're also going to be talking about the order of operations. I know I've been saying that to different points in the class, but this is where we're really going to get deeper into it. We're also going to talk about absolute values. Now that we know about negatives, that 0 is neither negative or positive, and also positives, and order and how to do math with them, we're also going to talk about absolute values. Algebraic expressions, what are the different ways that you can express values using algebra, and then we'll be talking about polynomials. Polynomial, unlike the word mono, which means one, poly means many, and nominal, many numbers. Okay, so let's start off with scientific notation. I'm going to go ahead and erase this. Okay, so unlike other powers, scientific notation is based on using powers of 10. So with that, you can actually go on to like very small numbers, as in, like with many decimal places before and after the 0. So let me get the markers out. So the way that we write these powers of 10, so this is really just powers of 10. So remember here, the number that we have here, this is called our base. And then the other number over here is called your power. So here with powers of 10, we're actually going to be doing this. 10 to the power of 1 is the same number, 10. So we do 10 to the power of 2, 10 to the power of 3, 4. So if we go ahead and do this, we're actually going to end up with 100, because it's the same thing as 10 times 10. Alright, here we have this 3 times. It's going to be 1,000. Here we're going to have 10 times 10 times 10. We're going to multiply 10 4 times because we have 2 to the power of 4. Okay. So now we also want to talk about negative powers with our powers of 10. Okay. So 10 to the power of negative 1, pretty much it's going to be 1 to the 10th to the power of 1. Knowing that our negative power just turns this into a fraction. The same as 0.1. You go ahead and do this over here. I'm seeing that there's a bit of shadow and also a bit of glare on the board. There we go. Keep on doing it. Let's see, is it too small? Let's try to write bigger. Same thing as so I'm working these out because I want to show you this overarching thing. 10, now that we look at it like that, we notice that the higher the exponent, when you have the base of 10, the values get bigger. There's more zeros at the end. Versus if you are putting, if our value is bigger or further away from 0, but it's negative, the value is going to be moving more and more decimal places. So here, from -1 to -4, we actually have a smaller number. So that's something we want to write down. So over here we're going to have 10 to the, let's just visualize this on a number line. Okay, so as you're increasing this value, like let's say that 10 to the power of 6, I know it's going to be an even greater number in this direction. If I do 10 to the power of -6, it's going to be even smaller, a smaller value over here. Okay, so we have it internalized. So the beautiful thing about working with tens is that you just get to shift decimal places. Truly, the difference between this one and this. So we have 10 to the power of 3 is 1,000. But if I wanted to make it 10 to the power of 4, here's the invisible decimal place. I would just move the decimal place one direction to the right because power is greater. We're moving in this direction. It's really 10,000. Likewise, if I'm going to a lower value for the power, I can just move it in the opposite direction. So let's do 10 to the -1 and then 10 to the -2. So 10 to the -1 is the same as 0.1. What we could do instead is have this. And since we know negative moves to the left of the number line, we're going to move it once to the left. So really, it's 0.01. I know there's another invisible 0 right here. I'm just going to go ahead and write it down. That way you guys can see that the dot or decimal place is not a straight mark. It really helps you out whenever you're writing things down with math. Is whenever you're writing decimals is to write the 0 in front of the decimal point. Excuse me. Okay, so we have this concept internalized. Let's do a couple of questions in order to further cement it. And if you have any questions, don't hesitate to ask. That's the point of the whole chat. Or you can even text me during the live stream if you have a question. I also get notifications if you comment below on the video, so I can go ahead and just go back if you have a question if you're reviewing this later. So let me know. I'll go ahead and erase this. So with these powers of 10, great, we have this concept down. Are we actually going to get problems with powers of 10 to the powers of 10? Not really. Like 10 to the power of 5, great. We know it's 10 times 10 times 10 times 10 times 10. But what we do, our scientific notation, is that we use the power of 10 to multiply by something else. Let me show you. Like 6.2 times 10 to the power of 5. Some of you may ask, well, okay, so it's just a fancier way of writing something down. This comes very much in hand when you're dealing more with science, specifically with biology, medication dosages, and particularly chemistry, pharmaceutical applications, even engineering. You're going to deal with something called significant figures. We'll be getting into that into the science class. You just need to know this concept. Once you master this concept, then it'll be a breeze when we cover that in high science portion. So right here with this is now considered scientific notation. Because we have a value times something to the power of 10. It's not really, I know the verbiage makes it seem like there's something to the power of 10. Power of 10 does not mean 10 as the power, like as in the exponent. So that's why we just, once we internalize the concept, we just let go of power of the 10, and we're just going to be seeing it now with another value. We're going to kind of marry it together. So here, what is the actual value? So this is scientific notation. Let me... the fancy smanchy way. And then there's something called standard form. That's what we are used to seeing in everyday life. So this, okay. So knowing on our number line, so we have 6.2 right here. And we know on our number line right here. So we have 10 to the power of 5. Great. I know 5 is positive. It's on the right side of the number line, or right of 0. So I am going to move the decimal place 5 times because it's 5, to the right. And to the right because 5 is to the right of 0. So we're going to go 1, 2, 3, 4, 5. So we rewrite this. And also add in commas. So this value right here is called standard form. All right, now you can also expect questions that will ask you to go from standard form into scientific notation. Great way to switch is anything that's 0, that's like right, all of these zeros, those can be converted into scientific notation. But if I have a value that's like this, I'm going to be able to remove these zeros, these 3 zeros. But since this 0 is sandwiched in, I can't touch that. In fact, I may have to write it like this. Okay, so here's the decimal point. 1, 2, 3, 4, 5. I would have to write this value as that. Keeping in mind any other digit that is not 0. Okay, so let's do another example. Be always very mindful of how many little bumps. It's happened to me before when I've done calculations and I miscounted the bumps and it changes my answer whether I'm going from standard form or to scientific notation. Okay. Next, we're going to be going from scientific notation to standard form using a negative exponent. Remember, the power, that's called the exponent. The little floater right here. No. So this is scientific notation. And we want to go to standard form. Okay, so going back on our number line, we have 0. We're talking about this exponent. This exponent is to the left. It's 3 times to the left. So I'm going to move the decimal point this way. So I have 3.82, and I'm going to move it to the left. 1, 2, 3. Oops. Should have done that with more room. So just copy down this value right here. Just copy it down. Now we're going to move 3 times to the left. 1, 2, 3. Then now copy this down as 0.00382. This is now my answer in standard form. All right, now we know what standard form is and how to get it back into like more common method. So let's do the reverse. Let's say that we are using a number that's used in everyday life, we write it in standard form, and we want to go into scientific notation. So let's do this backwards. Right, so what we know from multiplication, addition, and subtraction and division is that you are always going to undo it by doing the opposite. So here we moved to get to the standard form, we had to move it to negative 3, 3 times to the left. In order to go backwards, we're probably going to have to do the opposite. So let's see. I'm going to go ahead and erase. Okay, so let's get this value. So this is actually the distance in miles that a spacecraft took to reach Mars. So that would be the distance from Earth to Mars. So we want to convert this into scientific notation. I don't want to go ahead and say 440 million. It might be too much of a mouthful. So in order to also reduce error, like when I'm like typing things in multiple times or doing calculations, I would just go ahead and convert this into scientific notation. So this is called the standard form. Okay. So the decimal point is right here. And the good spot to move it, and we're going to move this decimal point until there's only one digit to the left of the decimal. So I'm only going to move it. I'm not going to do it here because there's still one more digit over here. I can't move it over here, the decimal point, because then I'm going to end with a value less than 1. So I will only move it up to here. And this is your rule forever with scientific notation. So I'm going to do 4.4 times 10. Okay, is it going to be positive? Is it going to be negative? First, let's count. 1, 2, 3, 4. 4, 5, 6, 7, 8. Need to be 8. So a neat way to just keep in mind that it's going to be a positive number instead of a negative number is just count from left to right. I know that there was a whole lot of words of like left to right, right to left. Just take it easy. It's I'm going to be emailing some homework assignments so you can go ahead and practice. It's okay if you get some wrong. If you get them wrong, it's just going to keep on showing you, okay, let's not do it this way. It's going to internalize the information into the proper way. So here we have, and also a great way to know intuitively that it's going to be a positive value is because this is a big number. If this was a negative 8, it would actually be like 0.00000000. So big number needs a positive exponent. Small number, negative number means like a very small number. So actually that would be 2, 3, 4, 5, 6. I miscounted. This one would be, so that's the difference between positive exponent and negative exponent. Negative exponent, smaller value because this is going to be now in the bottom of and the fraction is going to be the denominator. Okay. This is where we can get away with not remembering left to right, just knowing positive, bigger number, negative exponent, smaller. Okay. Let's do another one. So here we have 1, 2, 3. So we have this rate. We want to convert it now into scientific notation. The way we see it, plain, layman's terms, that is standard form. Let's go into scientific notation. Right, so we're going to be moving our decimal point so that there is only one number other than 0 that is to the left. So our goal is right here. So we're going to move it 1, 2, 3, 4. We're going to move it 4 times. So 1.6 times 10. I know it's 4 times, but since this is a really small number, power, it's going to have a negative power. So it's going to be 1.6 times 10 to the power of negative 4. Something I do want to point out is that in some calculators, they might even do a shorthand of the times 10. They might just write it like this. These are one and the same. It's just the calculator may just express it like this. And this just helps free up space. You might even be able to type in the E directly into your calculator. In some calculators, it might have it like this. And it might just type it out like this. Just be very mindful of which button is used on which calculator. I know that most of us don't read manuals with our calculators, but if there's like just an unusual button and you're not so sure what it is, look it up in the manual for that specific calculator and double check. If you don't know what that button does or you're not so sure, just don't use it. Just go ahead and type it out the long way in your calculator if you're doing calculations. Great if you know how to use this. If you don't worry. You'll just have to use like 2 more keystrokes or button strokes to get to the same value. Okay, so that was it with scientific notation. Woo-hoo! Now we're going to be talking about the order of operations. The order of operation dictates like when we have a lot of processes going into like a formula, it lets us know what processes are going to go first, second, third, and therefore, because if we actually don't follow the order of operations, we might get different numbers from each other. Have you all seen some challenges that people do? I think I've seen them on Facebook, but like where they put a bunch of numbers where they're doing addition, subtraction, division, and they're asking people what are the numbers they got, and people get different numbers. Truly, there's only one right answer, and that is if you follow the order of operations. So we're going to show you how to win. So order of operations. This is talking about priority. Order of operations. So in order of operations, we have a little acronym, and you've heard me say it before, it's PEMDAS. Parentheses. There's also like other grouping symbols. There's some of them that are like this. There's some that are like brackets. And then we have the curly brackets. If you do like computer programming, you might see a lot more of this and this and this. Exponents, that's just what we're talking about. And roots, because really if roots and exponents, they're very similar. Next, we have multiplication. Then we have division. Next, we have addition. Then subtraction. Now, there's another like underlying rule to all this. And this is why people who don't know the rule might get a different answer. is that multiplication, division, addition, and subtraction is performed from left to right. There we go. Just like in English, we read from left to right. Same thing, multiplication, division, addition, and subtraction. We're going to do that from left to right. We don't necessarily have to worry about parentheses and exponents being from left to right because like it's already like next to the number. They're kind of like married together. You can't really escape the brackets. You're kind of in a bubble. So that doesn't have to be done left to right. So let's do an example to remember this. Also, if you're kind of shaky on your order of operations, guess what? Your calculator knows this rule. It's programmed with PEMDAS. So if you get like a really long calculation, you can just punch it in and your calculator might get it right. But just be very mindful that you need to go ahead and start using your parentheses where it is required. Otherwise, your calculator will get confused. Oh, unable to connect to chat. Okay. If there's a problem with the chat, let me go ahead and just check the phone in case anyone has sent me a message. Oh. Okay, so someone did send me an email, and since the chat's not enabled, I can't see who is the one who's like viewing right now. So I'm just gonna send just a quick message just to verify. So if you're the one watching, just go ahead and check to see if I sent you a message. If you don't receive a message from me in like the next 10 seconds, go ahead and text me. That way I know you're the one watching the video. Oh, just 1 second. And no, this isn't like a James Bond kind of movie. It's just technical difficulties with long distance learning. Oh, okay. Yeah. Okay, so there's actually a student who wasn't able to access it. This is a live stream. Alright, just gonna take care of this very quickly. Don't want anyone else to get further behind than what they already are. Okay, so YouTube 7. Alright, let's check this out. Oh, it doesn't even remove the uploader. Okay, so let me share the stream. Ah, it's got a different code. Okay, yeah, that was feedback from the live stream. I'm going to send this to the students. Okay, copy, paste, send via email. Lesson. So I assume that the student who is able to be watching right now is probably one who subscribed and was able to see the link to this. Okay. Send messages. Link. Okay. Alright, just emailed the new link. Okay. Let's see. So, start that. Keep that tab open, that way I can see notifications if I get contacted in a different way. Okay. Alright, so for those of you who are watching right now, let's just go ahead and just take a 10-minute break right now. I'll give a chance for everyone else to connect, and I'll just brief them on what we just covered. So just go ahead and take a break. 10 minutes. And to come back at 6:55. is there 400? It's not 404, it's 400. So moved. What are the settings for this? Sent. Right, why is it private? That must be the issue. Oh, let's see. What? Okay, so I think the issue is that with the live stream, there was like an older live stream and it kind of was superimposed onto this current live stream. And since that live stream's already like ended and like posted as a playlist, it's causing like a server error. So I'm trying to go ahead and fix that. Yeah. That is very unusual. Okay, let's see. So that's okay. I see someone has popped in. Let's check the participants. Okay. Awesome. Okay. Great. Phew. Okay, I don't. Okay, so let me just fix. I don't know what happened with the titles that I had put up. So right before you came in, we were discussing scientific notation. And I was just covering the order of operations. Then we're going to be moving into the absolute value. Algebraic expressions. And if we have time today, we're going to be covering polynomials. Like that. Okay. Close this. Okay, I'm going to go ahead and see the page. Very quickly. Just want to make sure the connection and everything is working. Okay. Live. So I'm in the control room. So I'm seeing everything is 49. Okay. So, just as a quick recap, the great thing with the live stream is that you can always just go right back into it. We were talking about the order of operations, which is parentheses, exponents, roots, multiplication, division, addition, and subtraction. With these, you know that first, when you look at an equation, the first thing you're going to deal with are the parentheses. The next thing you're going to deal with are the exponents and the roots. Great thing about the exponents and the roots is that they're kind of already married to each other. You can't really separate an exponent from the number that it's with. So like I have 10 to the power of 2. There's no real way I can separate. Versus like with multiplication, division, addition, and subtraction, I have the signs of plus sign, minus sign, division, and multiplication sign. Those I can kind of like just separate those, and then as I now get to my order, like order of priority, once I get down to multiplication, I'm gonna perform the mathematical operations from left to right. English, we read from left to right. Same thing with math, we read from left to right. Division, then we're going to look at anything that involves division. If there's no division, we just keep on moving on. If there is division, we're going to read it from left to right. We're going to execute it from left to right. We move on to addition. If there's addition, we take care of it. If there's subtraction, we take care of that. Let me just move tabs here. Great. So now I'm going to go ahead and erase this because we're going to be talking about algebraic expressions. I really, really want to cover expressions. Great thing is that when we were talking about scientific notation is that you don't really need to know that other than doing like, we're not going to really build on that anymore. It's kind of like a one and done. So we talked about order of operations. Let's get into absolute values. Again, just like scientific notation, what we cover with absolute value is if you don't see the absolute value symbol, then you don't deal with it. This is not going to build on any other things. So let me go ahead and erase. So with absolute value, we have, like, let's say here we have a value of -5. But if we have this symbol around it, these lines on the sides mean absolute value. So truly, with absolute value, it basically means if there's a negative sign, just ignore it. Everything just becomes positive. I like absolute values. Sometimes if you're looking like at bank statements and like credits, debits, and like accounting terms, it might be very difficult to like internalize like a negative $500, but if you might say a $500 withdrawal from your account, that might be easier to understand. So instead of just being looking at your bank statement and just seeing the negative 500, because it depends if you're looking at it from the perspective of the bank or your perspective, those plus or minus signs will change. Because for you, a negative $500 is sad, but for the bank, they're adding $500 to their assets. So if we just see it as $500, or in this case 5, we just see it for the value that it is, the absolute value. We don't care about negative signs. Basically means ignore negative signs. Okay. So let's say I did the absolute value with a positive number. Cool. Doesn't mean anything. Since it's already positive, it doesn't change. With negatives, we turn them to positives. It's kind of like forcing negative people to be happy. So now I have a question. So let's erase actually. Make some more room. So we have a -13. Absolute value of -13. Is it equal to -13? Or is it equal to 13? If we write it down like this, like let's say we get a question that says, what value is equal to this? And it has different answer choices. And these are among 2 of the answer choices that you could pick. The answer is going to be 13. Because after we kind of indoctrinate or we consider it brainwashing, the absolute value, the negative, we kind of like force it to smile. And it's now happy, so we forget about the negative things, and now it's 13. We forget all about that negative. After the absolute value is done, there is absolutely no negativity left behind. So, how do we deal with this with mathematical operations? Okay. We're going to be using our PEMDAS in a way. So let's look at this. So So whenever you're writing your absolute values, try to make them like a little taller and deeper than your other values. That way you don't mistake it for one. It's happened to me before. Okay, so the absolute values kind of looks like a parentheses. So I'm going to deal with what's inside of this parentheses first, as I've done this. So I'm just going to drop down the negative 20, and I think I need to simplify this. 17 minus 34, that's negative 17. I'm allowing this negative number to exist for now, because I'm just simplifying. I haven't really had the absolute value symbols work their magic and eliminate all negativity yet. All right? So I simplified it to this. Next, now I'm going to have like the absolute value do its thing. Once you have the absolute value work, think of it as like a one time only, and like once you use it, you just drop it. Like here, we had negative 13, the absolute value negative 13, and we just rewrote it as 13. At that point, we don't need the symbols anymore. It did its job. We don't need it. So here, we're just going to rewrite it as negative 20. Now, the absolute value is going to do its work. Absolute value negative 17. We're going to drop that negative, and we're just going to rewrite it as 17. But just to like keep everything together, and since those absolute values were acting like parentheses, we're just going to rewrite it as a parentheses now. It's going to make sense logically, and it's going to keep us from trying to write this as negative 2017. By doing this, we preserve the integrity of knowing that we need to multiply these two values together. So now I can multiply negative 20 by 17. That is equal to negative 340. Pretty cool, huh? Pretty cool. So let's go ahead and do a word problem with an absolute value, because it's very easy to see it conceptually. Now let's just try to integrate it further. Okay, so there's no questions yet. Let's do the word problem. Okay. So the temperature in Northtown at 9 p.m. was negative 5 degrees Fahrenheit by 5 a.m. the next day or the following morning. The temperature was a negative 15 degrees Fahrenheit. It's kind of hard to imagine negative degrees right now, since down here in South Texas, it's pretty hot. So it's asking by how many degrees did the temperature change? Okay, so initially the temperature was -5 degrees Fahrenheit. And let's just draw a little thermometer. Let's use a red color. I wonder if you can see that. And it was at -5. And then it moved down to -15 degrees. So we want to know what was the change. We don't care at that point. We just want to know what was the change. Colder, hotter, doesn't matter. What was the absolute value? The way that we're going to set this up is intuitively we can do the mental math and know, okay, it changed by 10 degrees. But how do we set this up as an equation? It might even, on the high set, it can't even ask you what might be the equation that you use to solve for this. This becomes particularly important whenever you're trying to solve for systems of equations later on as we get into applying polynomials and systems of equations. So this is a skill that needs to be developed. So changes by 10 degrees. Okay, just making sure that there is no lag between the videos. Okay, I think I need to use a couple of different colors here. So we're going to deal with the absolute value. So here, when we're talking about change, we're asking about the difference. So whenever we're asking about change, you're going to subtract because you have a starting point and you have a finish point. You want to find out what's the difference, what's the change, subtraction. So here we're going to set up our absolute value because we just care about the change. We don't care what direction it was in. So let's just do this, our absolute value. And we're going to have to subtract. We're going to have to subtract these two values from each other. So just how we read from left to right, and what's left is first, we're going to set up the problem by having the first value that ever occurred, what happened at 9 p.m. that night, and was followed by the next morning. We know that the temperature at 9 p.m. was first before what happened the next day. So just intuitively, from what happens first to then what happens next, we're going to set up the equation like this. So -5 degrees, which we know it's degrees. We're going to subtract it because we're looking for the difference. And here it's very important to write parentheses because let's say, set it up like that. So it's going to be set up like this. So chronologically, this is first. Chronologically, this happened afterwards. There's our difference, our subtraction, because we know the change, and then absolute value, because we don't care what the change is. So let's go ahead and simplify. Something I do want to point out, when you're writing this down or you're typing into a calculator, you might be doing yourself a favor by writing it in the parentheses, these negatives, because you might forget, like, subtract, negative, two different things. Because those symbols look so similar when we write them down, just be very careful. So let's go ahead and simplify. So we have -5 minus -15. We're going to rewrite this. We're going to just drop down the -5 because there's nothing to do here. We're following our rules of PEMDAS. So we're talking about parentheses. Well, inside these parentheses, there's nothing to really deal with. Exponents, no exponents, but multiplication there is. Check it out. Remember how I said whenever you're subtracting by something and there's no number next to it, it's actually an invisible one. Because if you multiply by 1, divide by 1, it's always going to be the same value. So really, we're multiplying -15 by a -1. So this is going to turn into a positive, or plus 15 in this case. Also, if you don't want to deal with like multiplying or like trying to remember what I said before. Negative and a negative, they become buddies and they become a positive. If you start doing this between the exam, they might look at you funny, but it's okay. So we have this. So now we have the absolute value of -5 plus 15. That's going to end up to be 10. So we're just going to carry on the symbol of absolute value because we really haven't had it work yet. So -5 plus 15 is 10. Now we can have the absolute value symbols work on it. Well, there's nothing to work on because this is already a positive value. So in that case, we're just going to drop them. So our answer is 10. There is a 10-degree change. Ta-da! Okay. So there's no questions. I'll go ahead and erase. If we see like there's any weird pauses, it's because I'm noticing that there's a delay between the live stream and myself. Okay. All right. I'll go ahead and erase. Okay, we're going to be talking about algebraic expressions. So an algebraic expression uses things from numbers, operations, like our order of operations, and variables. And it uses these three things to demonstrate relationships between numbers. So if you see an equation like this, plus b, here, this is an algebraic expression. We are using well, so let's say I have here we can use the numbers, as seen right here. We can use variables, which are our placeholders, the unknowns, or things that we would plug in, like our letters, y, mx, b, y, and a, and c. Our operations would be our addition, our subtraction, our addition and multiplication right here. Here we have a lot of multiplication going on. So with that, we're able to see what are the relationships between numbers. So let me go ahead and do an example. That way we can see, like, okay, what's a number relationship? Like, what's the importance of it? Great things about number relationships is that it can actually observe like phenomenon and then like record it. That way you can make predictions. That's the whole thing about math. Recording the past to predict the present, and having knowledge is power. So let me go ahead and erase. So before we do a question, I think it's very important to see algebra and to see like what it means, like in symbols and in words, because we're gonna have to be translating things. Usually the question is gonna be asking you in words, kind of implied, and then you're gonna have to like construct an algebraic expression using symbols. So let's say I have here the product of 5 and a number. Okay, so this is going back to our definitions. Product means the whatever we get after multiplying. So we know we're going to multiply 5 and the unknown number. So in that case, I'm just going to use the curly x. So 5 times a curly x, which I can rewrite in many different ways. I can rewrite it like this, like as we've seen in our previous lessons, or I can just write it like this. I honestly prefer to write it this way. It's a lot easier, but let's say I'm plugging into a calculator, this might be easier, or if you like to cheat just a little bit, doing this, you're actually able to like save on like pressing this symbol and this symbol. So it's a little faster. And we like speed, but we love accuracy more. Let's do another conversion from words into symbols. A number decreased by 12. Okay, decreased means less, sounds like subtraction. So we're going to get a number, let's use our curly x, and decrease by 12, minus 12. It's not going to be this. No, not this. Because, and here it comes again, we read English from left to right. So we're going to set up our problem from left to right. What comes first? That's what we're going to deal with. Okay. I'm going to go ahead and do more questions. Feel free to snap into the chat and ask a question. Let me go ahead and do that. Okay, let me go ahead and erase this. Next, we have the sum of 3 and the square of a number. The sum of 3 and the square of a number. Okay. So sum, that means addition, right? Because that is an operation, I can't put that at the beginning of my equation. It's gotta have to be sandwiched between two different things. Okay, so now this is for the left to right. It's gonna come into play. The next thing I read is gonna be the first thing on this side of my operation. So sum of 3, okay, it's gonna go right here. And then it's gonna be kind of separated by the word and. So and is gonna say hey, we're done with the number or variable we're gonna be putting to the left side of the operation. Now we're gonna be talking about what's on the right side of the operation. So now what we have is the square of a number. Square of a number. So we know when we're talking about the square of something, it's something to the power of 2. Oh, okay. So what it's really talking about is x squared. Honestly, I prefer to deal with mathematical symbols using algebraic expressions and symbol. Writing this, someone who's not too comfortable or someone who gets tongue-tied, they might state this very differently, which results in a different expression, like when I'm trying to interpret it. So this is the beauty of algebraic expressions written as symbols. And then from there, you can just look at it and just see trends, plug in just very quickly. This is where you can use all your math power. Okay, so we did this question. Let's go ahead and do just a few more. The reason I'm gonna keep on doing just a few more practice with this is because this is the basis of all word problems, and there's going to be quite a few word problems that we're going to encounter in the high set. So let me just keep track. So next we have 6 less than the quotient of a number and 2. All right. So when I'm talking about 6 less, this is going to kind of change how I read things from left to right. I'm talking that I'm going to subtract 6 from whatever follows over here. So really, I'm talking over here about the quotient. So 6 less than all of this. So let me deal with this first. I can't really subtract from something, I don't know what. It's like you can't withdraw money from a bank account if you don't know the routing number and account number. So here we have quotient. That means division. Great. I have a number and 2. So number's going to go first. The reason I know that the number is going to be the numerator is because the numerator comes first. It's like, same thing I did this. Same thing as that, which is the same thing as that. Ta-da! Great. Okay. So quotient and number and 2. And then all of that is going to be less than 6. This is why I prefer algebraic expressions written out in formulas. Someone might have meant something else instead of this. Okay, so let's do something with like more stuff going on, a wordier expression. Let me go ahead and erase. One half a number increased by 15. I will warn you, this actually looks pretty short, like word count wise, but there's actually a whole lot of different operations going on. Excuse me. Okay, so we're talking about one half a number increase. So increase is talking about plus 15. So right now I know there's going to be a plus 15. So one half of a number, I can write it as one half x or x divided by 2. Take your pick. So I'll just write it as x over 2 plus 15. So if I wasn't being careful, like typing into a calculator or anything, I might actually be trying to say, I might type it in wrong and the calculator might interpret this very different. This value is going to be larger than this one most of the time because of the 15. 15 as a whole number versus 15 being added to the denominator, very different. Okay, so let's go ahead and do a practice problem. A true word problem. Go ahead and erase. Oh my, the whiteboard's getting pretty grainy. Okay. So, Sarah handles accounting for a bookstore. So here we're talking specifically about like online shipping, which is like a really hot topic lately. So let's say the shipping and handling on an order equal to 4% of the total cost of the order. So let me just go ahead and move this. I need to adjust something with the light. Okay, that should help with the glare. So we were at order is equal to 4% of the total cost of the order plus 95 cents per book. If, let me just do, C represents total cost and N, curly N, represents the number of books in the order, comma, which expression can be used to find the shipping and handling for an order. So we will be finding an expression, creating an expression, and that expression is going to show the relationship to the cost of the book and also the number of books that ordered to then calculate the shipping and handling fees. I think this is why Amazon Prime became so popular, because people didn't have to deal with these extra expressions. They pay, like, depending on what kind of plan you have. Oh, if you're a student, you can get Amazon Prime for students, which is like half of their annual fee. And then from then, if there's a Prime product, you will more than likely not have to pay for shipping and handling fees. All of that is going to be like already included in the cost, and it kind of just makes things easier. You see $5 and you don't have to like worry about shipping and handling fees. You don't have to worry about making expressions. And it might be easier for accounting too. Accounting as in like the people in the accounting department. So let's go ahead and simplify this. There's like so many words like right here. Okay, so like, okay, it's nice that Sarah works at accounting, and like you can kind of tell it's a bookstore already, so let's just erase that. Okay, the shipping handling on an order is equal to, okay, so shipping and handling is equal to, let's use a different color. Oh my. Shipping and handling is equal to 4% of the total cost of the order. So 4% of the total cost of the order. So what is total cost of the order? Oh, C represents total cost of the order. So let's just do this. Total cost of the order. Let's use this. Okay. And then it says 4% of the total cost of the order plus 95 cents per book. So I'm going to use plus, right here it says plus per book, and n represents the number of books per order. So it's going to be this times n. All right. So let's go ahead and simplify this. Really, 4% can be rewritten as a fraction. Because like 4%, same thing as 4 over 100, which is the same thing as this. So let's just kind of tidy up a bit. Right? Plus, let's just drop the dollar sign. And this is our expression. Now we know the relationship between the number of books, the total cost, and figuring out the shipping and handling cost. So here there's two variables. And actually we have the operation of addition here, but we also have multiplication going on right here. That's pretty neat. So let's say that we get a problem where like you find the expression or they even tell you the expression. More than likely they won't tell you the expression. Then they actually might, aside from setting up the expression, they're gonna want you to like solve for no. They're gonna tell you, let's say, a list of different books and their prices, and then it's gonna tell you said person ordered these specific books from the list, and then you're gonna have to like calculate the total cost of the books, and then you're gonna have to count how many books it was. So you're gonna find out the number, and then it might ask you the overall problem. What was the total the amount for shipping and handling, and then it's gonna ask you, okay, so what's everything the customer paid, like aside from the cost of the book, and then the shipping and handling. So it's like there's so many ways that this type of problem can be built up. This is why it's very important to set up your expression correctly. If you got to go back and look at it again, go back and look at it. Because there's a saying, garbage in, garbage out. If you start off with something wrong, you're going to end up with something wrong. So now we're going to talk about simplifying and evaluating expressions. We kind of already did that a little bit with this problem, but we're going to be going more into detail. And I think we aren't going to go into polynomials today. We're going to deal with that tomorrow. Oops. Let me move the computer that way. Okay. So simplifying and evaluating expressions. So simplify. That basically means you're gonna like do every single operation in it. Get down to the nitty-gritty until the only thing that's left for you to do is to plug in the unknown, which is the variable. Okay. Something else, like since you're dealing with variables, you can only add or subtract like terms. So like term or a term is a variable that have the same power. Sorry. Term is a variable is the same variable with the same power. So like I have x and y. I can't really mix that, but I have like x and then adding another x. Well, I can just simplify that as 2x, right? X plus x equals 2x. But x plus y, I mean, they're not the same, so I can't really do anything about it. And just to like further drive home what term means, term is basically anything in the expression. It can mean a number, or variable, or even the product / quotient of numbers and variables. So let me give you some examples. 5x. 5x is a product of a number and a variable. Whereas like 5 is just a number, x is just a variable, but 5x is a product. Or if I have x divided by 2, that is a quotient of a number and a variable. Something else I do want to point out is like whenever you have like especially a variable of x, you want to put what number you're multiplying with at the beginning, because if I do x5, which is mathematically correct, the way I drew my x, it might look like times 5. Make life easier, just put the number before the variable. Same thing how 5y is the same thing as y5. In the algebra community, we accept this as the standard of beauty. Okay, so let's get an expression and simplify it. Let's go ahead and erase. So you get question says simplify 2x minus 5 plus 4x squared minus 8 plus 6x. 2x minus 5 plus 4x squared minus 8 plus the product of 6 times x. All right, so let's start off with the highest power. So whenever you're going to be dealing with a mathematical simplifying expressions, you're always going to want to have the highest power listed first. It's kind of like if you think about royalty, like king and queen, nobles, and like common people, you're kind of going to list them by power. So 4x squared, is there anything else with the same power as x? Here also I want to point out is that the only variable we're dealing with are x's. There's no y's, a's, z's. We're just dealing with x. So we just have 4x to the power 2, and there's nothing like it. Okay, 4x squared. All right, we got some other variables going on. We have 2x and 6x. No other like them, power of 1, really. So now I'm going to be able to combine 2x with 6x. Right, because this is positive, this is positive. Now, the only things I have left to deal with are my actual numbers, -5 and -8. So, I am just going to go ahead and do minus, or I can just go ahead and add, and just drop in the minus right here, and just turn it into a negative over here. And then I could do -8 over here. I could do -5 plus -8, but that's a little bit of overkill. It is correct, but you're going to end up being just very nitty-gritty. You can, if you wish, there's nothing wrong with it. So let's further simplify. 2x plus 6x is 8x. And then we have -5. Ooh, let's look at our number line. We've got 0, we've got -5. And we're going to subtract by 8. We're going to move it further away from the 0. So this value is actually -13. Let's say I actually decided to deal with my numbers first, and then the x, and then the highest power of x. I'd have to rewrite the equation like this, just so it's again by the standard of beauty in algebra. Big news! Now, there are two other things that we will cover. It's the distributive property. Now, this is like where I'm talking about like when you're multiplying something outside of the parentheses and then like it applies to everything inside. So let's do this. So we have distributive property. So distribute, like if you're like people are distributing meals to the homeless, they're kind of like giving something to others. We call it the distributive property. So great thing about distributive property in math is it allows you to group symbols or to remove said grouping symbols to simplify expressions. So let's use simplify expressions by removing grouping symbols. Let me use an example to demonstrate. So let's say I have A times the sum of, which I'm going to go ahead and write in parentheses, plus B plus C. So this is distribution. So instead of having, this literally means A times B is AB, and then A times C, which I'm going to go ahead and add. But since A is a common factor, I can just go ahead and like move it out to the outside, and it might be easier. Especially like, let's say I was dealing with like 3, 5, 7 variables. Like, let's say I was dealing with this instead. This would be easier than having to deal with yeah. Much prettier. Distributive property just like removes the common element and then it lets you know, hey, this is what we're dealing with. So let's do like a couple more examples because I know this is like still pretty fresh and it might be reminding some people of algebra and kind of like giving them scary flashbacks. So let me go ahead and erase. Still talking about distributive property. Same thing applies if you're having to do other operations. It doesn't just work with sums, it also works with subtraction. So let's say I have A multiplied by the difference, subtraction, of B and C. Really, I'm just going to go ahead and like multiply this. It's going to equal AB. And just multiply this, that, minus AC. For those of you that are kind of not seeing like what's going like behind the scenes, let me kind of like expand this further. What I'm really doing is doing A times B minus A times C. I'm doing this right here, and I'm going to distribute it. So like, let's say that there's 2 homeless people, and I'm giving out food to homeless people. I'm going to give out food to this homeless person and to this homeless person. But since they're both people that need food, I'm just going to eliminate the common factor. And this just makes it easier to group things together. So let's do a problem. I'm going to go ahead and erase this. So let's say you get a problem that asks, simplify 4x minus 3 times the sum of x plus 9, and then we're going to add 15. Simplify this. All right, so PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. I gotta deal with that. PEMDAS has never led anyone astray. So we're gonna make this equation easier. Big way that you can do that is instead of subtracting, you turn everything into adding. So like, how do you make this equivalent? You add a negative number, same thing as subtracting. So let me write this down here at the bottom. There we go. So what we're going to do now is that we're going to kind of like just rewrite it. But first, we kind of need to like distribute this 3 first before we do anything crazy. Because right here there's an x trapped in here, but I can't really free it because like the negative 3 still hasn't done its work on it, and I can't really free this 9 to combine it with this other number because like the negative 3 still hasn't done its work. So first I need to do distribution, parentheses right here. It's a special kind of distribution. So here we're gonna actually just go ahead and simplify this as plus negative 3 times x plus negative 3 times 9 plus 15. Okay, so let's go ahead and further simplify that. All right, so plus negative 3x. And then plus negative, that's just a 6. Plus 15. Let me just double check my math from my notes. I'm sorry, multiply, not add. It's supposed to be plus negative 27. This is very important. If I'm able to do mistakes, it's very likely that someone else can also do mistakes. So just always double check your work as you're going through it. All right, so let me drop the 15 over here. All right. I can kind of like already simplify the funny business. Right, because addition, adding a negative number is the same thing as subtracting. And I can even say well, what do you know? These two numbers just happen to be right next to each other, and x's are x's. It's not x squared with x. They're both x's to the same power. I can just like combine these guys together. That's pretty cool. So I can then simplify from this. So x minus 3x. Hey, that's just 1x. And then adding, well, this is really a negative number because negative 27 plus 15 is going to be 12. So x plus negative 12, gotta further simplify. My simplified expression is x minus 12. Whoa. If I have to deal with an expression and then I gotta like go back and like plug in an x, sure, like this might be telling me like some like complex relationship and like great, but when I just want to like plug in and know my final value, this is what I prefer to deal with. And this should equal the same thing. All right, so next is we're gonna go ahead and evaluate. So evaluate evaluate an expression means to find its value. So by doing that, we're gonna go ahead and need to assign a number for each variable. This is something that I think might be best covered tomorrow. What I really like to do is instead of like completely moving on from a section is to kind of do like a little mini recap at the beginning of the following class. So we'll just go ahead and talk about evaluating an expression tomorrow. So this is it for this live stream. I'm gonna go ahead and send some like practice homework as well as like the links to talk with tutoring. That way you can get more of that one-on-one connection and you have like unlimited tutoring access. But I think that they are operating using Zoom. All right, that's it. Have a good night, everyone. And